Hello wonderful person, this is Anton, and in this video we're now going to be solving one of the major mysteries from the James Webb, and specifically a mystery in regards to an object that appeared to be extremely far away, and specifically the object right here. And while here, imagine you're using the world's most powerful telescope, the James Webb, and you find something that appears to be the oldest, most distant galaxy ever seen. Something that's at the redshift of 32, or appearing to have formed just 90 million years following the Big Bang. Something that modern cosmology believed to be pretty much impossible. And that's exactly what happened last year, and we've actually discussed this in the video in the description, with scientists discovering a few of these objects that appear to be at ridiculously high redshifts. With this discovery essentially breaking some of the current models when it comes to the universe. But as you're going to learn today, this turned out to be a case of a mistaken identity, and a very intriguing one as well. Because it turns out that this is not a galaxy at all, but something entirely different. And so let's discuss what this is, talk about the initial discovery and why this was so unusual, and of course discuss exactly what this is and how we know so. And so let's try to understand how and why this happened. But in order to start, we first have to figure out how we usually find these objects and how scientists identify them and know that they're so far away. And in essence here, astronomers usually rely on a technique referred to as a dropout method. And here's a visual example. This is based on the idea that the universe is expanding and that the light from very distant galaxies gets stretched into longer and redder wavelengths. A process referred to as the redshift. And so because of this redshift, some of the most distant candidates are often called dropouts because they're just ridiculously far away, and some of their light becomes completely shifted out of the visible range. And it might only show up in the infrared range, visible to telescopes like the James Webb. And so if an object is invisible in shorter wavelengths, but suddenly appears in the longest ones, it's usually a prime candidate for being a galaxy from the very beginning of time. And so here these dropouts are basically just super far away objects, at least in theory. But as we've discussed last year, a few such candidates made the headlines because they really appear to be super far away. And one such object we discussed last year, Capotauro, appeared to have a redshift of 32. For context, the current record holder for being the most faraway galaxy only has a redshift of 14. That's a galaxy you can learn about in a video in the description. And so with the redshift of 32, it would mean that this galaxy is approximately 200 to 300 million years younger and seems to exist in a universe that's 90 million years old. And at that time, according to the current models, galaxies simply should not have enough time to grow into objects visible from such ridiculous distances. And that meant that something here just doesn't add up. Either this is some kind of a bizarre object, such as for example maybe a black hole or something, or this is something entirely different and we're just misreading the data. But while some scientists were trying to figure out exactly what this object was, another team of astronomers was actually exploring a different region, the famous Bullet Cluster. This is a galactic cluster famous for its visual representation of dark matter, or basically a cluster where we actually see regular matter and dark matter in slightly different locations. And while here, completely by accident, they found two objects referred to as Bullet BD1 and Bullet BD2. And on paper, these looked like the ultimate early universe candidates. They were basically infrared dropouts. They were only visible in some of the reddest filters. And so once again, if these were galaxies, they would be at the redshift of 20 to maybe 30. Very similar to those previous objects discussed last year. And to try to figure out what this was, astronomers did something crucial. They waited. They essentially waited for the second set of images approximately a year after the first in order to see if there were any changes. And here they used the near-infrared observations in order to also get chemical fingerprints or spectrum of the light. And well, the results were a complete game changer. Because here the first piece of evidence was proper motion. And in astronomy, proper motion is the actual movement of an object across the night skies, usually relative to some kind of a distant background star. And well, as you can imagine, a galaxy at the edge of the universe should not be doing that. As a matter of fact, it should appear as one of those background stars. And so it should never appear to move. But these two objects in the bullet cluster did move, and by quite a large amount, approximately 49 milliarcseconds per year. That's actually pretty big for a deep space observation, with these movements proving beyond any doubt that these were right here in the Milky Way galaxy. These were not distant galaxies. They just looked like distant galaxies. Which of course raises the next question. Okay, so what is it then? Well, if you followed astronomy long enough, you can probably already guess what. These seem to be brown dwarfs, with the spectroscopy revealing that they are extremely cool white dwarfs, possibly representing failed stars, with the average temperature of about 350 to approximately 410 Kelvin. And so these were essentially a type of a failed star. And though much more massive than planets like Jupiter, in terms of size, they were very similar to Jupiter, but just not quite heavy enough to start nuclear fusion. And since these were white-type dwarfs, they were basically the coldest known type. As a matter of fact, in terms of temperature, their surface is just a little bit hotter than the surface of planet Earth. Here you can basically compare this to a kind of a warm cup of tea. As a matter of fact, the bullet BD1 seems to be one of the lowest temperature brown dwarfs ever discovered with spectroscopy, which makes this quite an exciting observation. But this is also exciting because they're not that close, approximately 1000 to 1300 light years away from us, making these some of the most distant cool brown dwarfs discovered so far. And here, based on their temperature, we can also assume that they're probably very, very old. And that's because to become so cold, they have to have been cooling for billions of years, and very likely traveled across the galaxy for billions of years longer than the Sun. But because they only emit infrared light at this point, and specifically deep infrared, it just so happens that it seems to be the exactly same wavelength that we expect from a distant galaxy as well. Which is of course why they were first misinterpreted as these ridiculously distant galaxies, and which is why scientists now think this is very likely something extremely similar. As a matter of fact, based on the study, scientists are now pretty certain Capotauro is also a brown dwarf because it seems to have extremely similar profile in terms of spectroscopy. And so the main question here is why these objects misinterpreted, and how can we avoid this in the future? Because technically brown dwarfs and galaxies should not actually look the same, and scientists generally understand how to tell one apart from the other. Or essentially the question is, how did the professional astronomers get this so wrong? Well, there seem to be three main reasons. First, the so-called Lyman alpha break mimicry. The atmospheres on these brown dwarfs seem to contain things like methane and water vapor that absorbs very specific wavelengths of light, and this actually creates a sharp break in their light spectrum that surprisingly looks almost identical to the light break we normally see inside galaxies that are super far away, the break referred to as the Lyman alpha. So this is what a brown dwarf looks like, and here's what we usually see in these super distant galaxies. So they do look very similar. Then, they obviously both have a point-like appearance. Since both the galaxies and these brown dwarfs are so ridiculously far away, and since both of them are so small, they essentially appear as these tiny points of infrared light in many James Webb images. But on top of this, the third reason is the luminosity and dust. Sometimes we assume a very red object is a galaxy hidden behind a lot of dust, but these white dwarfs are actually naturally red, and they mimic this dusty look perfectly. Which means that quite a few similar objects have very likely been misinterpreted as galaxies, which is essentially one of the main discoveries from this particular study, with researchers additionally discovering that the fields at low galactic latitudes, or basically areas of the sky much closer to the disk of the Milky Way galaxy, are much more likely to contain these brown dwarf imposters and are less likely to contain distant galaxies. Which of course makes sense. We're more likely to find these objects inside the galactic disk and not outside of it. Which obviously means that if we don't account for all of this, we might end up filling our catalogs with a lot of these record-breaking galaxies that are simply just brown dwarfs masquerading as a different object. But discovering these brown dwarfs is also exciting for scientists studying stellar and planetary evolution. Mostly because these brown dwarfs are also kind of rare. These are extremely old and very cold objects that kind of help us understand how stars evolved and how they were formed in the beginning. And so by finding these two unique objects, it allows us to figure out exactly where a lot of brown dwarfs are hiding and how many of them were created in the galaxy itself. Because at the moment, the overall hypothesis is that brown dwarfs are essentially created very similar to stars, but just don't get enough mass to become stars over time. And so by finding more of these objects, we can either confirm or disprove this idea. But when it comes to Capotauro, it obviously still has a bit of a chance. Mostly because even though it resembles these brown dwarfs, there have not been a conclusive study yet to disprove that this is not a galaxy. In other words, right now scientists suspect that this is a brown dwarf very similar in temperature, but until we get more data, sometimes in 2026, it's going to be difficult to confirm this. And so if scientists discover that it's also moving across the night skies and also seems to contain very similar spectral properties, this would be a telltale sign that this is a brown dwarf too. And surprisingly, this might also suggest that Milky Way might contain way more brown dwarfs than we ever anticipated, because quite a lot of them seem to photobomb a lot of pictures, even though scientists did not expect that many. And so the main takeaway so far is that usually astronomers do not just trust one image, and especially they don't trust images of one type. And that's because a pretty picture only tells you that there is something there. It doesn't tell you what this is. And so this study essentially confirms that extraordinary claims indeed require extraordinary evidence. And even though we did not find super distant galaxies here, scientists did discover something just as exciting and just as rare: the coldest, most elusive members of our own galactic family. And that means that James Webb, even without trying, is continuously surprising us and teaching us so much more even about our own galaxy. On that note, we'll come back and discuss this more in some of the future videos once there are some updates or new discoveries. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.